Leaders, champions, welcome to neotisa. This is Physics 003. This is Physics 003, where we are going to talk about magnetism, electromagnetism, and electromagnetic induction. This topic is very important. Every year you have 7 questions on it in your multiple choice question, MCQ. And in the essay part, you will see question on it. 003 are for magnetism, electromagnetism, electromagnetic induction, alternating current, and direct current. And those topics are very easy. We are here to give you the best. And if you want any class, we have paid class. We offer a paid class where we do everything so that you can understand better. But today, we are going to talk about this. There are differences between these 3. We have magnetism, electromagnetism, and electromagnetic induction. 3 of them are related, but they are not the same. 3 of them are related, they are not the same. And they are there in your scheme of work. Let me quickly explain the 3, so that when we are taking them one after the other, we know what we are doing. So that we won't be lost in the process. What is magnetism? Magnetism just deal with what? The magnet and electric world are magnetic field only. Let me repeat myself. Magnetism, it deals with what? Magnet and what? Earth's magnetic field. No electricity is involved. Write it down. Magnetism. This first one. Magnetism. It deals with the study of magnets, Earth's magnetic field, and no electricity is required. Write it down. 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 Okay, they can see me proper now. Okay, please. Okay, I'm sorry. Okay, look at it. I said, it deals with what? Magnets, Earth magnetic field, and no electricity is what? Required under magnetism. That is magnetism. We are going to talk about what? Magnetic bar. We are going to talk about what? Magnetic what? Materials. Which are what? Diamagnetic material, ferromagnetic material, paramagnetic material. Then we talk about what? Earth's magnetic field. We talk about the property of what? Magnet. Then no electricity is what? Required. Take note. Then what is electromagnetism? Electromagnetism. What is electromagnetism? What is electromagnetism? What is electromagnetism? In this one, from the word electromagnetism, that is electricity producing magnetic field. Electromagnetism. Don't forget, magnetism is what? Magnetic field. Then when you now have electromagnetism, electricity producing magnetic what? Field. That means we use electricity, we use current, electric current, to produce a magnetic what? Field. That is electromagnetism. Write it down. Electromagnetism. It deals with electricity producing magnetic field, where we use electric current to produce magnetic field. Simple. That means it deals with what? Electricity producing what? Magnetic field. A situation we use what? Electric current to produce what? A magnetic field. Under this, what are we going to study? We are going to look at current carrying conductor. We are going to look at this. Current carrying what? Conductor. We are going to look at current carrying what? Conductor. We are going to look at force on a current carrying conductor. We are going to look at what? Force on a current carrying conductor. We are going to look at what? Force on a current carrying what? Conductor. We are going to look at that. We are going to look at the magnetic field around a conducting wire. Around a conducting wire. Those are the things we are going to study here. Then we are going to study solenoid and electromagnet under this one. That's just it. This one, we are going to study magnets and what? Earth magnetic field without what? Electricity. Property of magnets. Those are the things we are going to study here. But under this one deals with what? Producing of magnetic field using what? Electricity. Where electricity produces what? Magnetic field. Under it, we are going to look at a current carrying what? Conductor. We are going to look on what? At what? Force on the current carrying what? Conductor. And we are going to look at magnetic field around the conducting what? Wire. We are going to look at what? Solenoid and what? Electromagnet under this one. This one is just electricity. Using electricity to produce what? Magnetic field. This one is just magnet and properties of magnet. Our earth magnetic field. That's what we are going to study here. Then the last one, which is electromagnetic induction. Electromagnetic induction. Please, if you need, we have a paid class. You can contact any one of the two numbers on the admin. You can send message to them, or the numbers will be on the comment section. If you need a paid class where we study fully everything in Japan from 01 to 04 in a simple way, that we give you how the question do come, the way we set questions. Please. What is electromagnetic induction? Electromagnetic induction. Very simple. This one just deals with what? Using what? Magnetic field to produce what? Electricity. Where magnetic field, a magnet, is used to produce electricity. Reverse of this one. This one, electricity is used to produce what? Magnetic field. This one is what? Magnetic field is used to produce what? Electricity. Write it down. A situation where electric field produces what? Magnetic field rather produces what? Electric current, induced EMF. It deals with, in this case, magnetic field produces induced EMF or current. EMF or current. That is that. In this case, electric field produces what? Induced what? EMF or current. Magnetic field rather produces induced EMF or current. Magnetic field produces induced EMF or current. Reverse of this. Hope that you've understood the three. This one, we only study magnetic bar, magnetic property. We study earth magnetic field. No electricity is involved. In this one, we use electricity to produce magnetic field. In this one, we study a current carrying conductor. In this one, we study a force on a current carrying conductor. We study solenoid and electromagnet in this one. But in this one, magnetic field produce what? Induced EMF or current. What are we going to study here? We are going to look at, in this one, we are going to look at what? Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. Faraday's law. That is, the law talks about what? Using what? Magnetic field to produce what? Electric current. We are going to look at what? Lenz's law. This one just talk about what? The direction of the induced EMF. The direction of induced EMF. This one is what? This law talks about what? Using magnetic field to produce what? Electricity. This one talks about the direction of induced EMF. And the consequences of Lenz's law is what? Conservation of energy. Take note. Juppé 2022. The consequences of what? Lenz's law is what? Conservation of energy. The consequences of Lenz's law is conservation of energy. When we get there, we explain better. Take note. Those are the things we are going to look at in this one. We are going to look at Faraday's laws of electromagnetic induction. We have two laws postulated by Faraday, first law and second law. Then we have Lenz's law. Take note of that. Then let's move. Those are the differences between the three. Hope that you understood now. If I say magnetism, you know what it means. If I say electromagnetism, you know what it means. If I say electromagnetic induction, you know what it means. Magnetism, no electricity. Electromagnetism, using electricity to produce magnetic field. Electromagnetic induction, using what? Magnetic field to produce what? Electricity. Take note of that. Then let's take the first one. Magnetism. Let's take the first one. Magnetism. I said under this we are going to talk about what? A magnet bar. We are going to look at what? The Earth magnetic field. Don't forget, the Earth acts as a giant magnetic bar. The Earth acts as a what? Giant magnetic bar that has what? Magnetic north and magnetic what? Circle. The Earth that we are on is like a what? Magnetic bar. That is what we are going to talk on this one. And before we talk on that, look at this. where you have a magnet is a substance that has north pole and what? South pole. A magnet is a substance that has what? A north pole and a what? South pole. If a magnet is divided into two, you cut this magnet into two, what will happen? You cut it into two, like this. It will still have the north and what? South pole. Take note. If I cut this one into two again, into smaller two, it will still possess the north pole, south pole, north pole, south pole. If I cut this one into two, it will still possess, cut it into two, it will still possess the north, south, north, south. But the difference between them is that the polarity of this one will be the strongest. Because as you are cutting it into smaller parts, the north pole and south pole will be formed, but the polarity, the concentration, the strength of the word polarity will be reducing. Take note. Take note. Take note. Take note. If you cut it, you see how the north and south, cut it north and south. But the difference is that the strength of the polarity reduces. Take note of that. Then, a magnet, whenever it is suspended freely on the earth, what will happen? When you have this, look at this. Look at this. I told you the earth is like a what? The earth is like a magnet, a giant. The earth, this is the globe. The earth is like a giant magnet. Then this is what? Geographical north. This is what? Geographical south. The earth acts like a magnet. Where you have is like a magnet. You have the south, you have the north. Don't forget, lipo repair, on lipo attract, north pole attract south pole in magnetic band. North and north repair each other. South and south repair each other, but north and south attract each other. Don't forget. Hope that you've seen a magnet before. North and south pole of a magnet attract, but north and north repair, south and south repair. This is the earth that has a big magnet in it. The earth has a big magnet in it. This is a big magnet inside the earth. Then the south of the magnet is facing the north of the earth. That means this is the geographical north of the earth, the true north. This is what geographical south of the earth, which is the true south. But the north of the world, of the magnet, is seeking the south pole. The south of the magnet is seeking the what? North pole. That is, in the earth, we have a giant magnetic bar. That the south is facing the what? The north. Because north attracts what? South. The north is facing the what? South. North attracts what? South. Take note. Then we have what we call magnetic north. That means this north, this south is called the magnetic north. Why? Because the south is facing the what? Geographical north. The south of this world magnetic band inside the earth is a giant magnet inside the earth. That's why they say the earth behaves like a magnet. The earth behaves like a magnet because we believe that it has a giant magnet in it, in which the south is facing geographical north. And that south that is facing the geographical north, we call it magnetic north. Then the north that is facing the geographical south is called what? Magnetic what? South. Magnetic south. Then don't forget, the difference between the what? The geographical meridian and what? Magnetic meridian is what we call what? What we call angle of declination. I will still explain. Just take note of this. When you have the Earth, inside the Earth, we have a giant magnet, in which the south of the giant magnet is facing the north, the true north of the Earth. Then we have the north of the giant magnet facing the true south, which is geographical south of the world, of the Earth. That north is called magnetic south. Some people can say magnetic north. You can still call it magnetic north, or you can say magnetic south. Magnetic south, that means the north of the magnet is facing the geographical south. Magnetic, that means the south of the magnet is facing the world geographical north. Take note of that. Then from here, what are the things you're supposed to know about the Earth's magnetic field? The Earth's magnetic field. The Earth magnetic field. Before I move, what is what? Magnetic field. Let me explain that one first. Magnetic field. What is a magnetic field? A magnetic field. Right, magnetic field. Magnetic field. This is a region. This is a region. This is a region around a magnet that experiences magnetic force. Write down. This is a region around a magnet. This is a region around a magnet that experiences magnetic force. Write it down. That is magnetic field. This is a region around a magnet that experiences magnetic force. A region surrounding a magnetic bar that experiences magnetic force is called magnetic field. The region around a magnetic bar that experiences magnetic force is called magnetic field. Take note. Take note. Take note. Take note. Take note of that. Write it down. Right. Please take note. Let's move. Magnetic field, a region around a magnetic bar that experiences magnetic force is known as magnetic field. The region around the magnetic bar that experiences magnetic force. Let's move. Let's move. Let's move. Because of time, we are going to quickly look at there are some parameters under Earth's magnetic field. Parameters as angle of inclination, angle of declination. Those, let us quickly look at that because of time. They are angle of declination. Angle of declination, which is also known as angle of variation or magnetic declination, which is also known as this. Angle of declination, magnetic declination. What is the meaning of angle of variation or angle of declination? Right. This is the angle. Because of time, this is the angle. This is the angle. This is the angle between. This is the angle between geographic meridian and magnetic meridian. Write that. Magnetic declination or angle of declination. This is the angle between geographic meridian and magnetic what? Meridian. The angle between geographic meridian and what? Magnetic meridian. The angle between geographic meridian and what? Magnetic meridian. The angle between geographic meridian and magnetic what? Meridian. That is angle of declination. Angle of what? Declination. Or magnetic declination or angle of variation. The angle between geographic meridian and what? Magnetic meridian. The angle between geographic meridian and magnetic meridian. The angle between them. We have angle of D. Next one. Angle of D. Angle of D. Or angle. This one is there in your past question. Or angle of inclination. Inclination. Or angle of inclination. Or magnetic D. Angle of D or angle of inclination. Angle of D or angle of inclination. This is the angle. This is the angle between the horizontal component. The horizontal component and Earth magnetic field and Earth magnetic field and Earth magnetic field. Take note of that. This is the angle between the horizontal component and Earth magnetic field. The angle between the horizontal component and Earth magnetic field. Please don't count it. Angle of declination. The angle between geographic meridian and magnetic meridian. Angle of D. The angle between the horizontal component and Earth magnetic field. What do they mean by that? Let me quickly explain this. This one is this. The angle, this one. The angle between geographic meridian or geographical north and magnetic what north. Angle of declination. The angle between them. Magnetic north. Geographical north. The angle between them. The angle of the angle between the horizontal component and what? The Earth magnetic field. This is what they mean. Let me draw it. If a magnet is suspended freely, is suspended, you have a magnet. You tie a magnet to a rope. It is suspended freely. It is suspended freely. You have something like this. If it is suspended freely, that means you have the north seeking pole and you have the south seeking pole. Then don't forget, this is horizontal component. The angle here, the angle between this Earth magnetic field and this horizontal component is what? Angle of D. Angle of D. The angle between the Earth magnetic field and the horizontal component, this angle is angle of D. While angle of declination is the angle between the geographical north and magnetic north. Geographical north and magnetic north, that is angle of declination. But angle of D is the angle between the what? When you suspend a magnet freely, suspend it with a rope, it moves, it stays in diagonal. Where you have angle of D could be formed. The angle between the what? The Earth magnetic field and the horizontal component, that is angle of D. When the magnetic bar is suspended. Take note of that. Take note of that. Take note of that. Then the last one for now, within 2 minutes, because of time, please, if you need class, you can contact us. So that all this thing is very simple to have your A in Japan. Physics A, chemistry A. It's very simple. For these 3 months now, you need us. and the money is very cheap. We are going to give you back-to-back online class, back-to-back. You can contact us. Tell your friends, we need like 100 students. We want to give you the best nationwide. We want to give you the best. Take note of that. Let me quickly give you this. Let me quickly give you this. Let me quickly give you this. Because they are there in your past question. 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 Look at this. If I draw this one out, I will have something like this. I have something like this. The angle that is here, that is angle of D or angle of inclination. This is what? Horizontal component. This is vertical component. BH, horizontal earth magnetic component. Horizontal component of earth magnetic field equal to what? B cos theta, where this one is B. Why this one is what? The vertical component of earth magnetic field, which is equal to what? B sine theta. Take note of this. Where BH, then BH is horizontal component of earth magnetic field. BV, vertical component of earth magnetic field. Then V is what? Total magnetic field. Total magnetic field. Take note, there's difference between magnetic field and magnetic flux. That question came as 2020, number 32. Number 32 or 37. What is the unit of magnetic flux? The unit of magnetic flux is different from the unit of magnetic field. Take note, the unit of magnetic flux. Magnetic flux is not the same to magnetic field. It's not the same. Take note, 2020, number 32 or 37. Japan, 2020, 32 or 37. Magnetic field is not the same thing as magnetic flux. But magnetic field, this magnetic field, because of time, I don't have much time, take note. Magnetic field is also known as magnetic flux density. This one, they are the same. Magnetic field is known as magnetic flux density. The unit is what? Tesla. Or Weber per meter square. Take note, Tesla or this. That is magnetic field or magnetic flux density. And the symbol is what? B, capital B. Why the unit of this one? The unit of this one is what? Weber. The unit of this one. 2020. Japan. Take note of that. Then quickly write it down. That means the horizontal component of earth magnetic field is what? Magnetic field cos theta. The vertical component of earth magnetic field is what? Magnetic field sine what? Theta. Then take note, at the equator, angle of D is what? Equal to 0. Write it down. At magnetic equator, angle of D equal to what? 0. Write it down, please, because you need it. 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 Then you need it. No, at magnetic equator. At magnetic equator, angle of D is equal to what? 0. At magnetic equator, angle of D equal to what? 0. At magnetic equator, angle of D is equal to what? 0. Then what are we going to have? We have BH equal to what? B cos theta. At magnetic equator, angle of D is what? 0. Therefore, BH is equal to what? B cos 0. Isn't it? Then we have BH equal to B. What is cos 0? 1. Cos 0 is what? 1. That means times 1. That means BH will be equal to what? B. That means BH is maximum at the magnetic equator. Write it down, please write it down, so that in less 1 minute you can call it a day. Take note, at magnetic equator, angle of D equal to what? 0. Then for horizontal component, we have BH equal to B cos theta. At the equator, theta is what? 0. D is what? 0. Change it. We have this. That is BH equal to what? B. Because cos 0 is what? 1. We have BH equal to 0. That means at equator, magnetic equator, BH, the horizontal component of magnetic field, of Earth magnetic field, is what? Maximum. Take note of that. Then what will happen to BV at this equator? What will happen to BV? Hope that you've written it down. Magnetic field is the same thing as magnetic flux density. The unit is Tesla or this. While magnetic flux is what? Weber. The symbol for this one is phi. The symbol for this phi. I'm sorry. This is phi. The symbol for magnetic flux is what? Phi. Take note. 2020, number 32 or number 37, prepare. They ask you. Take note of that. Let me quickly run up this. Then, what will be at equator, at magnetic equator, we know that angle of D equal to what? 0. What will happen to BV? BV will be what? B sine theta. Then BV will be equal to what? B sine theta is what? 0. Therefore, BV equal sine 0 is what? 0. 0 times B will be what? 0. This one will be what? BV will be equal to 0 at the equator. Then let's look at magnetic pole. What will happen? Which is the last one? At magnetic pole. At magnetic pole. Please take note of this one. At magnetic equator, angle of D equal to 0. What will be BH? It will be maximum. BV will be what? 0. Then at magnetic pole, angle of D will be equal to what? 90 degrees. Take note of that. At magnetic pole, angle of D is what? 90 degrees. Therefore, what will happen to BH? BH is what? B cos theta. Isn't it? Therefore, we have BH equal to what? B cos, what is theta? 90. Then we have BH equal to, what is cos 90? 0. 0 times B will give you what? 0. That means BH is what? 0 at what? Magnetic pole. Then what will be BV at magnetic pole? BV equal to what? B sine theta. Take note. Therefore, we have BV equal to what? B sine, what is theta? Angle of D at magnetic pole, 90. Therefore, BV equal to what? B sine 90 is what? 1. Therefore, BV will be equal to what? B. That means BV is what? Maximum. is maximum. BV is maximum at magnetic pole. Magnetic pole. BV is what? Maximum at magnetic pole. Take note. BV is maximum at magnetic pole, while BH is what? Maximum at magnetic equator. BV is maximum at magnetic pole. BH is maximum at magnetic what? Equator. Take note. At magnetic pole, angle of dip is what? 90. At magnetic equator, angle of dip is what? 0. Please take note. Take note. Then both of them can be the same when angle of dip is 45. They can ask you. It's coming now. When we horizontal component of the earth magnetic field and vertical component of the earth magnetic field be the same. When would they be the same? When the word angle of dip is what? 45 degrees. Write it down. Last one. Write it down. Write it down. BH equal to what? BV. When angle of dip equal to what? 45 degrees. Take note of that. BH equal to what? BV. When angle of dip equal to what? 45 degrees. Take that down. Please, for more video, if you need coaching, you can join us because we have students for that we are teaching. You can join them also. You still have 3 months. Those 3 months, you won't regret it. The only thing you will regret is that you'll be blaming yourself that you should have started with us early. But you won't regret it because you still have A. You still have A because we are going to give you what you need. We are going to teach you there. As we are teaching you, we solve past question. Can you see I'm giving you from past question? Angle of dip is there in your past question. When can angle of dip be 0? At magnetic equator. What is the unit of our magnetic flux? Weber. I'm giving you. Because they will ask you. Magnetic flux is different from magnetic field. Magnetic field is the same thing. Magnetic field what? Magnetic flux density. Take note of that. If you need more video, if you need coaching, please DM us. I remain myself, Jama. May God bless you. Thank you.